This video is to show you how to use your graphing calculator to find derivatives so that you can be more efficient on the calculator questions. So we're going to use this question here to show you how from your calculator screen, your calculation screen, you can find the derivative. So this equation says, or this question says, find the equation of a tangent line. So we're finding the equation of a line, and it's tangent to this function. So we know that when we're talking about finding the equation of a tangent line, that we write that equation of that tangent line in point slope form. So it's y equals mx minus x1 plus y1. And so what we need to find here then is the slope, and we need an ordered pair x1 comma y1. And first I'm going to do this as if this were a no calculator question. So the first thing I'm going to go through is how to do this without a calculator. So we know that the coordinate x1 comma y1, we know the coordinate x1 is, or the coordinate x1 is 1, okay, because we know we want to find that tangent line at x equals 1. So we know this is 1. So we're going to find y1 by plugging in x into the function. So it's going to be 3x cubed. So that's going to be 3 times 1 cubed plus 2 times 1. Okay, so we know our y1 then, let's see, 1 cubed is 1, 1 times 3 is 3. Over here we have 2, so our y1 is 5. So we know we're talking about the point of tangency is 1 comma 5. Now we got to find the slope. And we know the slope is the same thing as the derivative dy dx. And since slope is a number, that means we have to evaluate the derivative at that point of tangency. So we have to evaluate the derivative when x is equal to 1. So the derivative of f of x, in other words, f prime of x, okay, f prime of x, doing our power rule here, is going to be 9x squared plus 2. Okay, so that's our derivative. So when I say derivative, you're thinking slope. So our slope then is when we evaluate that derivative. So we're going to take that derivative and we're going to plug in 1. We're going to evaluate it at the point of tangency. So when we plug in 1, we get 9 times 1 squared, that's all 9, plus 2 is 11. So this, let's see if I can change colors here. Not quite sure how to change colors. There we go. So this evaluation of the derivative and finding its value at x equals 1, this is what's going to be done on our calculator when we do this using a calculator, and that's going to save us some time. Okay, so now we know our slope is 11 and our point of tangency is 1 comma 5. Get back to black here. And so our tangent line then is y equals 11, going back up to this point slope form. Y equals 11x minus 1, because that's the point of tangency. plus 5. That's the y-coordinate of the point of tangency. So, so that's your tangent line. Now, if on a multiple choice question, chances are they might give this answer in slope-intercept form. We know that slope-point form is far more useful to us. But to match it up with a potential slope-intercept form, I'm just going to distribute here 11x minus 11 plus 5. And so the point slope form is 11x minus 6. So that's the tangent line. That's the equation for the tangent line. Okay, so let's do this using our calculator here now. So the idea is everything in red here we want to evaluate in our calculator. That allows us to avoid actually having to do the power rule and plug in this and evaluate it. So it'll allow us to avoid any mathematical errors that might occur when doing this. So we come up here, calculating derivatives. If you remember, I can just kind of annotate this over here. We'll put this in green. To do all of this on our calculator, we're using that math8 key. Okay, so coming over here now to our calculator, math option 8 is n-deriv, and you notice I'm going to just use the Leibniz notation as it looks like here, plug in x, and now I need to plug in the function, and so I'm going to go ahead and plug in, and this is actually, I'm going to back up here because I'm going to put, instead of typing in the function, which I could, let me just do that, 3x cubed plus 2x. So I can just plug in the function. I'm also going to show you how to graph this and plug in the graphed function. And we want to evaluate this at 1. So this whole situation here is going to calculate the derivative, take that derivative, plug in 1, and give you this answer for the slope. So when I hit enter, you can see we have 11. That's our slope. The reason why we have 0.000003 is because the calculator is calculating this numerically, and so it's getting into some rounding errors here. We know the slope is 11. We have to be smart enough to realize that that's going to lead to an integer answer. So our slope is 11, and so at that point, now we need to have the 5, and this is where we can actually go to our graphing calculator here, type in our function, 3x cubed, 3x cubed plus 2x. So, I mean, I realize it's not hard to plug in 1 here, but if you're even nervous about that, you can plug the function in here, and we're going to go to the table, so I'm going to do second, graph, and when x is equal to 1, y is equal to 5. So we can even get that information right from our calculator as well. And if we would have done this first, we actually could have gone to the graphing screen, and instead of typing this whole thing here, we could just type in y1, and let me show you how to do that. So back on my graphing calculator screen, I'm going to do a math9. Oops, that's not a math9. I'm going to do a math8, excuse me, and I'm going to plug in my x, and instead of typing this whole thing in, I'm going to get y1 by using the vars key. The vars keys for variables. So I'm going to go vars, and then I'm going to go my y vars, or my y variables, and I want to get that function. And that function is y1. And so I can actually type that right in there, and that will go into the grapher and grab this. And then evaluating it at 1, and as you can see, it gives us that 11. So that's how to approach using the graphing calculator to save you some time. Okay, and there's another way we can use the graphing calculator to save us a ton of time, and that is for when we want to find like extremas or maybe sometimes we call them critical values. In other words, when we want to find things like mins and maxes, and you know, like hills and valleys and stuff like that. So we're going to look at problem 17 to kind of discuss how to do that on our graphing calculator. First, we're going to do this without using a calculator. So kind of like we did back in the previous example. We're going to look at this and say, okay, it says find all points at which this graph has horizontal tangent lines. Okay, if the tangent line is horizontal, that means it's flat. So we know that a horizontal tangent line means I have a slope of equal to 0, which means my derivative, because if I'm thinking slope, I'm thinking derivative. My derivative is equal to 0, which means those are my hills and my valleys. And so we could ask this question many different ways. We could find the points of find all points which the graph has horizontal tangents. We could also ask to find mins and maxes. Or we could ask you to find hills and valleys. Or we could ask you to find critical points. So those are all the different ways of asking us to do the same thing. And that what we need to do is we need to find this derivative, and this is the key right here. We need to find that derivative and set it equal to 0 and solve for x. Okay, so that's exactly what we're going to do here. So like I said, we're going to do this without a calculator first. If this were on a no calculator part of the exam, you have to know how to do that. So let's go ahead and find the derivative here. So dy dx equals, now let's go ahead and differentiate that. So that's 3x squared minus 3. So there's our derivative. We want to know where our derivative is equal to 0. That's what this is saying here. Where's my derivative equal to 0? And we're going to solve this. So I'm going to factor out a 3. I'm going to have x squared minus 1 equals 0. And at this point, we could do a couple of things. We could divide by 3, and then, move the 1 over. But I really encourage you, anytime you have a quadratic, I really encourage you to factor, because anything else might eliminate a solution. So when we factor this, it factors into x minus 1 and x plus 1. And then we know that one of those has to be 0 for the product to be 0. So either x minus 1 equals 0 or x plus 1 equals 0. So that means we have horizontal tangent lines at x equals 1 and x equals negative 1. And so what are my y values in that scenario? Well, if I come back up here and plug in 1, I get 1 cubed minus 3 times 1. Notice I'm plugging that into the actual function, okay, because I want to know my y coordinate. So I'm not going back to the derivative, I'm going back to this function. So this is 1 minus 3, so this is negative 2. So this ordered pair is 1 comma negative 2. And then if I plug in negative 1 to the original function here, I will get negative 1 cubed minus 3 times negative 1. And so that is negative 1 plus 3, which is 2. Y equals 2. And so that's at negative 1 comma 2. So this must be our max. And this must be our min, because it has a smaller y value. Okay. So really, I've gone way beyond answering this question, because I just wanted to know where the horizontal tangent lines are, which are those two locations, x equals 1 and x equals minus 1. So how do you do this using your calculator? So I'm going to go ahead and clear out all this stuff here. And so what we can do if we want to find horizontal tangent lines is we can flat out graph this. So x cubed minus 3x. And right now I just have a standard window, so I'm going to go ahead and graph this. I guess I don't have a standard window, so I'm going to zoom standard 6, and that'll give us a nice window here. So we can see we have a max here and a min here. So these are the locations where we have horizontal tangent lines. So we can actually find those locations if we go into second calc and we look for either a value, a zero, a minimum, a maximum, point of intersection, a derivative, or something called an integral. So we want to find mins and maxes, because if we look at this graph, we know we have a max here at that location, which is where we have a critical point. So we know we have a horizontal tangent of 0, and we have a min here for all those same reasons. So I'm going to find this max and this min using my calculator functions. So in that case, I'm going to, on my calculator, I'm going to go after these locations by doing second calc min and second calc max. And that'll give us those locations so that we don't have to do any of this math. Okay, so if I come back to here, I'm going to do second calc, and I'm going to do I'll do the maximum first, second calc 4. Okay, so the calculator is asking me for a left bound. So I know the maximum's here. When it asks you for a left bound, that means it wants you to go to the left of that point and kind of lock in that this is where you start looking. So I'm going to hit enter because it's asking me a question. Left bound, question mark, hit enter. That sets your left bound. Now I'm going to arrow to the right on the other side of that maximum, and it's asking me for the right bound. In other words, where does it want to stop looking? So I'm going to hit that enter, and then it's going to ask me to guess. So I'm going to back off a little bit towards that max, because the closer I can get to that max, the less time it spends guessing. I'm going to do that, and there's our maximum. It's at x equals -1, just like we said over here. That the maximum here is at x equals -1. So we avoided all of that math just by putting it into the calculator here. Now let's go after the minimum. So back to our calculator, second calc. We're going to do a minimum, second calc 3. And we have to do the same thing. We've got to get a left bound. So right there. And then we've got to get a right bound. So we're going to arrow a little over. Hit enter, there's my right, there's my left. It's going to look in between there. I'm going to back off so that it's closer to where we're guessing. Hit enter, there's my minimum. It says 0.999996. But again, we're getting into the fact that the calculator is trying to calculate things numerically. And so it's really trying to do its best to approximate. So we're going to call that 1. So at x equals 1, we see a minimum. So that is at this location here, we see our minimum. So we can grab those, and notice it gives me the ordered pairs, 1, -2, 1, -2. So we can graph them that way. And then the last way we can talk about the derivative here is we can actually graph the derivative. This is kind of cool. So here's the function. I'm going to go down to y2, and I'm actually going to use my math 8 key, my math 8 key to get derivatives. And I'm actually going to plug in and physically calculate the derivative of equation y1. So I'm going to go to my vars again, go to my y vars, hit my function and y1. So I have the derivative of y1. And if I want to graph it, then here, since I don't want to find it at a specific value, I want to graph the whole thing, I put in another x. And what that is saying is that we want to graph function y1, this function, over all values of x. It takes a little while, but it's kind of cool that you can actually generate this. So if we think about this being a cubic, if we differentiate it, we get a quadratic, right? So we should get some sort of U-shaped thing for the derivative. So as we graph this here, here's the original graph, and in the red is our u-shaped derivative, right? So here's our cubic, here's our derivative. Notice that at this max, the red here has an intercept because the red represents a derivative. So at that hill, we have a derivative value of 0. Likewise, at this valley or this minimum, again, the red is the derivative. We have a derivative value of 0. So those are some ways you can use your calculator to really save you a lot of time and to avoid computational mistakes by doing everything by hand when you don't have